Hello student, welcome to my channel The Learn Physics. I have started the one-shot video of Ncert Physics class 12. I have already uploaded chapter 1 and chapter 2 of Ncert class 12. Now today I will be discussing the chapter 3 of Ncert Physics. Now the today's discussions are, look at this: electric current, current density, drift velocity, mobility, resistivity, conductivity, Ohm's law, derivation of Ohm's law from drift velocity, resistance and dependence of resistance on various factors, then combination of resistances, cell, EMF, internal resistance, terminal potential, combination of cells, that is series combination, parallel combination and mixed combination, Kirchhoff's law, wheatstone bridge, meter bridge, finally potentiometer, and all the numericals related to these topics will be discussed today. Okay, now let's start. Now look at this electric current and current density. First of all, average current. Suppose in time delta t, if delta q amount of charge flow through a conductor, then average current I average equals to delta q by delta t. Okay, its unit is coulomb per second or ampere. If a charged particle q rotates in a circular path of radius r with velocity v, then period of revolution is 2 pi r by v. So electric current due to rotation of the charged particle delta IB is equal to delta Q by delta T. Now delta Q equal to charge of the charged particle, that is Q, and delta T means its period of revolution, that is 2 pi r by v. So this is the QV by 2 pi r. This is equal to Q into frequency of revolution. Okay. Now look at this. These two formula will be extremely helpful for you to find the average current in a circuit. Okay. Now instantaneous current. The instantaneous current is the rate of charge flow with respect to time. Therefore instantaneous current is equal to dq by dt. Now from this equation we can calculate dq, that is I dt. So q equal to, look at this, q equal to integration of I dt from t1 to t2. Okay. Now current density is the current flow per unit area normal to the direction of flow of the current. So current density J equal to current divided by area of cross section normal to the direction of flow of the current. Now look at this, actually current is the, look at this, current is the dot product of current density vector and area vector. That is why current is a scalar quantity. Okay. Now I will be solving three numerical related to average current, instantaneous current and rotation of charge in a circular path. Look at this, current I equal to 10 plus 40 ampere flow through a conductor. Find charge flow in 10 seconds. Now we know I equal to, look at this, dq by dt. So look at this, dq by dt equal to 10 plus 4t. Now look at this, dq equal to 10 into dt plus 4t dt. Now integrating from 0 to 10 second, we get the charge. Look at this, integration dq 0 to q, here 10 dt, this is the 0 to 10, this is the 4 t dt, this is the 0 to 10. Okay, now this is the q, this is the 10 into t, this is the 10 0, now 4, this is the t square by 2, and this is the 10 0. Okay, now look at this, this is the 10 into 10 plus, look at this is the 2, so 2 into 10 square minus 0 square, so look at this, 100 plus 200, so there is 3, so therefore 300 coulomb. Okay, so amount of charge flow in 10 second is equal to 300 coulomb. Understood? Now next numerical. Look at this, in Bohr's orbit, electron revolves in a circular path of radius 0.53 angstrom with speed 2.2 into 10 to the power 6 meter per second. We have to calculate the current due to revolution of the electron. Now first of all, what is the current due to revolution of a charge? Now look at this, the current due to revolution of charge is frequency of revolution into charge. Now look at this, here frequency V by 2 pi r, and this is the Q equal to E. Now put the value, look at this is the 2.2 into 10 to the power 6, this is the 1.6 into 10 to the power minus 19. And now this is the 2 into 3.14, and radius is, look at, now radius is equal to 0.53 into 10. Now radius is equal to 0.53 into 10 to the power minus 10. Okay, the current becomes 1.1 into 10 to the power minus 3 ampere, that is 1.1 milliampere. Okay, understood? Now next, drift velocity, mobility, resistivity and conductivity. Now in this discussion we have to establish Vd equal to minus E tau by m equal to minus I by NAE, mobility mu equal to sigma by Ne equal to 1 by Ne rho. Okay, look at this, first of all drift velocity. The velocity gained by electron within the conductor due to electric field is applied in it. Suppose this is the positive potential and this is the negative potential. The potential difference between this point and this point is V. So electric field E equal to, look at this, V by N. Now due to this electric field, now electron moving in this direction. Now the force on each electron F equal to charge of electron into electric field. So this is the minus E into E. Now acceleration of the electron, look at this, this is the minus E by m. If tau be the relaxation time, that is time interval between two successive collision of electron due to its thermal motion, then drift velocity Vd equal to 0 plus A into tau. So this is the minus E tau by m. Okay, look at this, this is the drift velocity of electron. Okay, this relation is very important for you. Okay. Now next we have to express the current in terms of drift velocity. Now look at this. If Vd be the drift velocity of electron, distance traveled by electrons in 1 second is Vd. Now if A be the area of cross section of the conductor, so volume occupied by electron in 1 second is Vd into A. Look at this volume. If n be the number of free electron per unit volume, then total number of free electron in this volume capital N equal to small n A into Vd. So charge of electron in this volume, this delta Q equal to number of electron NaVd into minus E. So current I equal to, look at this is the delta Q by delta T. So this is the minus NaVdE divided by 1 because we consider 1 second. So look at this, here Vd is equal to, look at this is the I by minus NaE. So this is the expression of drift velocity in terms of current, and this is the drift velocity in terms of electric field. Now look at this, if electric field becomes double, then drift velocity also double. If the potential difference becomes double, then electric field also double, so drift velocity also double. If both potential difference and length increases to 2 times, look at this, electric field remain constant, so drift velocity also constant. Now from this expression, look at this, if area of cross section double, the drift velocity becomes half. If radius of cross section double, then area of cross section becomes 4 times. So drift velocity becomes 1 by 4 times. Okay. If current becomes double, then drift velocity also double. Okay. Understood? Now we have to derive the Ohm's law from concept of drift velocity. Look at this is the expression of drift velocity, this also the expression of drift velocity. Now equating this and this, we get, look at this is the minus E tau divided by M equal to minus I by NaE. Look at this, E equal to potential difference by length. Now put here. So negative cancel out. So EE, this is the V by ML equal to I by NaE. So look at this, V equal to M divided by N squared tau L by A into I. Look at this term, M divided by N squared tau is called resistivity of the conductor. So look at this, resistivity rho equal to L by resistivity rho into L by A into I. Understand? Next. Now look at this, rho L by A is the resistance of the conductor. So V equal to R into I. So V proportionate I is the Ohm's law. So Ohm's law is obtained from the concept of drift velocity. Okay. Now mobility. Look at this, mobility is the drift velocity per unit electric field. Mobility mu equal to Vd by E. Now look at this, Vd equal to minus EE tau by M. So look at this becomes minus EE tau by M into E. Okay. So look at this is the E look at this, the E tau by M. Look at this, from this expression, resistivity rho is equal to M by N square tau. So tau equal to M by N square rho. So this is the M by N square rho. So this is M by N square rho by M. Now this and this cancel out, this and this cancel out. So mobility mu equal to 1 by N E rho. Now resistivity rho is the inverse of conductivity. So look at this. This is the mu equal to sigma by N E. Therefore sigma equal to mu N E. This is the expression of conductivity in terms of mobility of electron. Understood? Now next. Now look at this Ncert numerical 3.13. The density of free electron per unit volume is 8.5 into 10 to the power 28 per meter cube. Okay? Area of cross section of the conductor 2 into 10 to the power minus 6 meter square, and current flow through this is A. Now we have to calculate the time taken by a free electron to move the distance 3 meter. Understood? Now let's start. First of all, drift velocity Vd equal to minus I by NAE. Look at this. This is the minus 3 ampere. N is the 8.5 into 10 to the power 28. A 2 into 10 to the power minus 6. And this is the minus 1.6 into 10 to the power minus 19. Look at this. This is the minus 6 and this is the minus 19. So this is the minus 25. Minus 25 plus 28. So 10 to the power 3. So look at this. 3 divided by 8.5 into 2 into 1.6 into 10 to the power minus 3 meter per second. Okay. This is the 0.11 into 10 to the power minus 3 meter per second. So this is the 0.11 millimeter per second. So look at this. Drift velocity of electron in a conductor is few millimeter per second, but current flow with speed of light, because current flow means the propagation of electric field. As the speed of electric field is the speed of light, that is why current flow with the speed of light. Okay. Now next numerical. Now look at this. The density of copper of area cross section 2 into 10 to the power minus 6 meter is 9000 kg per meter cube. Molecular weight 63. If current flow through this is 4 ampere and copper contains 1 free electron per atom, we have to calculate the drift velocity. Now look at this. Here area of cross section given, current given, charge of electron is known. Now we have to calculate the number of free electron per unit volume, that is small n. Now the molecular weight of copper 63, therefore 63 into 10 to the power minus 3 kg copper equivalent Avogadro number of atom. So this is the 6.023 into 10 to the power 23 atom. Now look at this. One atom contains 1 free electron. So atom can be replaced by free electron. So look at this. If it divided by its density, so we can get volume. So look at this. 63 10 to the power minus 3 divided by 9000. meter cube copper contains 6.023 into 10 to the power 23 free electron. Okay, now look at this. This is the 7 into 10 to the power minus 6 meter cube copper contains this. Now 1 meter cube copper contains 6/023 into 10 to the power 23 divided by 7 into 10 to the power minus 6. So this becomes 6/7 into 10 to the power 29 free electron. Okay. Now drift velocity Vd equal to minus I by NAE. Look at this, I equal to 4 ampere, N equal to 6/7 into 10 to the power 29, A equal to 2 into 10 to the power minus 6, and this is the minus 1.6 into 10 to the power minus 19. Now look at this. This is the minus 6 minus 19, that is minus 25, and this is the plus 29, so 10 to the power 4. Now this becomes, look at this, 2 into 7 divided by 6 into 1.6 into 10 to the power minus 4 meter per second. Now look at this, 6.96, that is 9.6. So look at this, this is the almost 1.4 into 10 to the power minus 4 meter per second. So this is the 0.14 millimeter per second. Okay, understood? Now next. Now Ohm's law. If material, temperature and other physical conditions of a conductor is fixed, then current flow through the conductor is directly proportional to the potential difference across the conductor. Now look at this. Suppose this is a conductor, current flow through is I. So potential difference, this is the A, this is the B. So VA minus VB proportionate I. Therefore, VA minus VB equal to V proportionate I. So V equal to Ri, where look at this, R equal to V by I is called resistance of the conductor. So according to Ohm's law, resistance is the ratio between potential difference across the conductor and current flow through it. Okay, its unit is volt per ampere or ohm. Now ohmic conductor, the conductors in which Ohm's law is obeyed is called ohmic conductor. All metals are ohmic conductor. Non-ohmic conductors, the conductors in which Ohm's law is not obeyed is called non-ohmic conductor. Non-metals are non-ohmic conductor. Okay, limitations of Ohm's law. The relation V proportionate I is not obeyed for large current. For large current, the graph becomes this. So V proportionate I is only true for small value of current. Now number 2, keeping magnitude constant, if polarity of V changes not, then V is not proportional to I. And finally, the relation between current and voltage is not unique. Look at this. For a given current, suppose I equal to I1, we get two different voltage V1 and V2. Okay. Now resistance. Resistance is the obstruction offered by a conductor when current flow through this. It depends on length of the conductor, that is R proportionate L, when area of cross section, temperature and material are constant, and R proportionate 1 by A, that is resistance is inversely proportional to area of cross section when length, temperature and material are constant. So combining these two relations we get R equals to rho L by A, where rho is the resistivity of the conductor. Now look at this, if L equal to 1, A equal to 1, then rho equal to capital R. So resistivity of a conductor is the resistance between two opposite faces of a unit cube. Okay. Now variation of resistance due to stretching or recasting. Look at this, the variation of resistance due to stretching are proportionate L square. From this relation we can derive the relation delta R by R is equal to 2 delta L by L, and variation of resistance due to recasting is, look at this, R proportionate 1 by R to the power 4. So look at this, here delta R by R equal to minus 4 delta R by R. Now we have to derive this relation. So this topic will be very interesting for you. Please like, share and comment on this. Look at this, resistance R equal to rho L by A. Now multiplying both numerator and denominator by L. So we get rho L square divided by A into L. Now again multiply by D, density of the material. So rho L square D divided by ALD. Now ALD is the mass of the substance. So look at this, this is the rho D by M into L square. Here R proportionate L square. Okay, so from this relation we can establish relation delta R by R equals to 2 delta L by L. Okay, that is if a wire stretched to increase twice its initial length, its resistance becomes 4 times. If it stretched 3 times, its resistance becomes 9 times. Now, if length of a wire stretched by 1%, so resistance increased by 2%. Stretched by 3%, resistance increased by 6%. Okay, understood? Now next. Now resistance due to recasting. Look at this, we know R equals to rho L by A. Now multiplying both numerator and denominator by A. So this is the A, this is the A. This is the rho L A density D divided by A square D. Okay. Now look at this, this is the mass M. So rho M by D into 1 by A square. Therefore R proportionate 1 by A square or R proportionate 1 by R to the power 4. So look at this, delta R by R is equal to minus 2 delta A by A, and here delta R by R equal to minus 4 delta R by R. Okay. Now these relations are very important for you. Now look at this, if a wire is recasted in such a way that radius becomes half of its initial value. So look at this, this is the 1 by half to the power 4. So this is the 16 times. So resistance increases to 16 times. Now look at this, if area of cross section becomes half of initial value, look at this, the resistance becomes 4 times. If area of cross section increased by 1%, then resistance decreased by 2%. If radius of cross section increased by 1%, look at this, the resistance decreased by 4%. Okay. Look at this, a numerical. A wire is stretched in such a way that its length is increased to 2 times of present value, and number B is increased by 1%. How? What will be the resistance in the first case, and in second case find the increment of resistance. Look at this, we know in first case R proportionate L square. Therefore R2 by R1 is equal to L2 by L1 whole square. Okay. Now look at this, L2 by L1 is equal to 2. So look at this, this is the 2 square equal to 4. So R2 equal to 4R. So R2 equal to 4R1. So resistance is increases to 4 times of its initial value. Now look at this, from this relation here delta R by R equals to 2 delta L by L. Now look at this, here delta L by L equal to 1%. So look at this, the increment of resistance delta R by R 2 into 1%, that is the 2%. So increment of resistance is 2%. Understood? Next. Look at this, a wire is recasted in such a way that its radius is increased by 2 times of its present radius and radius increased by 1%. Find the final resistance in this case, where initial resistance is 640 ohm and here change of resistance in this case. Now here data given is R2 by R1, this equal to 2. And delta R by R equal to plus 1%. Okay. Now look at this. If a wire is recasted, then variation of resistance with radius of cross section are proportionate R to the power 4. Now look at this, here R2 by R1, this equals to R1 by R2 to the power 4. Now here R2 by R1 is equal to 2, so R1 by R2 equal to half. Now look at this, this is the half to the power 4, so this is the 1 by 16. Now R2 equal to, look at this, R1 by 16. Now R1 equal to 640, so look at this, this is the 640 by 16, so this is the 40 ohm. Okay, no problem. Now second case, look at this, from this relation we can prove that the delta R by R equal to minus 4 delta R by R. Now look at this, delta R by R is the plus 1%, so look at this, this is the minus 4 into 1%, so this is the minus 4%. So radius of the wire is decreased by 4%. Understood? Now next, look at this, the variation of resistivity with temperature. For a metallic conductor, the resistivity of the conductor increases with rise of temperature, and for non-metallic conductor, the resistivity decreases with rise of temperature. Okay, if rho 0 and rho t be the resistivity at 0 degree and t degree Celsius, then look at this, rho t equal to rho 0 into 1 plus alpha into t, where alpha equal to rho t minus rho 0 divided by rho 0 into t is the temperature coefficient of resistivity. For a metallic conductor, alpha is positive, but for non-metallic conductor, the alpha is negative. For a substance like manganese and constantan have very low value of alpha. That is why these two substances are used to manufacture the standard resistance. Look at for copper, the rho t graph is straight line, but for a semiconductor, the rho t graph is, look at this, decreases with rise of temperature. Okay, understood? Now next, now variation of resistivity with temperature. Suppose a conductor having number density of free electron is n, relaxation time tau, then resistivity rho equal to m divided by n squared tau. If the temperature of the material increases, then thermal motion of the electron increases. So electrons have more frequent collisions with each other. Therefore, the relaxation time tau decreases. That is why the resistivity of metal increases with rise of temperature. The resistivity of the semiconductor is very high, whereas resistivity of metal less. Look at this. The resistivity inversely proportional to the number of free electron per unit volume. As the metals have more number of free electron per unit volume than that of semiconductor or insulator, that is why the magnitude of resistivity of semiconductor and insulator are very high. Okay, understood? Now next, now look at this Ncert 3.5. Look at this, the resistance of a heating element is 100 ohm at temperature 27 degrees Celsius, and at a temperature T2 resistance is 117 ohm. Alpha is given. We have to calculate temperature T2. The relation of resistance with temperature is given as RT equal to R0 into 1 plus alpha T. Okay. Now look at this. 100 equal to R0 into 1 plus alpha into 27. And again 117 is equal to R0 into 1 plus alpha into T. Okay. Now we have to calculate T where alpha is given. Now divide these two relations. So this is the 117 divided by 100, and this is the 1 plus alpha T divided by 1 plus 27 alpha. Okay. Now multiplying this, this is the 100 plus 100 alpha T. This is the 117 plus 27 into 117 into alpha. Now look at this. This is the 100 alpha T minus 27 into 117 alpha. This equal to 117 minus 100. So this is the 17. Here 100 alpha into T minus 27 into 1.17. Okay, equal to 17. Now T minus 27 into 1.17, and this is the 17 into alpha into 100. Now alpha is equal to, look at this, 1.7. So look at this, T minus 27 into 1.17. This is the 17 into, look at this, this is the 1.7 10 to the power minus 4 into 100. So look at this, this is the 17 by 1.7 into, look at this, this is the 100. So this is the 1000. Okay. So T equal to, this is the 1000 plus 27 into 1.17. So T almost equals to 1030. Okay. Understood? Now next. Now a silver wire has resistance 2.1 ohm at 27.5 degrees Celsius and R2 equal to 2.7 at 100 degrees Celsius. Now we have to calculate alpha, the temperature coefficient of resistance. Now look at this, RT equal to R0 into 1 plus alpha T. So look at this, from first equation 2.1 is equal to R0 into 1 plus alpha into 27.5. Okay. Now 2.7 equal to R0 into 1 plus alpha into 100. Okay. Now divide these two equations. So we get 2.7 by 2.1. This is the 1 plus 100 alpha divided by 1 plus 27.5 alpha. Okay. Now look at this, this is the 27 by 21. Now look at this, this is the 2.7 by 2.1. Now look at this, this is the 9 and this is the 7. So 9 by 7, this equals to 1 plus 100 alpha divided by 1 plus 27.5 alpha. From this equation we can write 7 plus 700 alpha equals to 9 plus 27.5 into 9 alpha. Okay, now look at this. This is the 700 minus 27.5 into 9 into alpha, this equal to 2. So alpha equals to 2 divided by 700 minus 27.5 into 9. Okay, this is the 4.5 into 10 to the power minus 4 per degree Celsius. Okay, now look at this. Resistances R1, R2, R3 are connected in series across a potential difference V. If I be the current flow through this, then potential drop across it V1 equal to IR1, potential drop across is V2 equal to IR2 and V3 equal to IR3. So total potential drop V1 equal to V2 plus V3 is equal to V. Okay, now put the values. So this is the I R1 plus I R2 plus I R3. If capital R be the equivalent capacitance in series combination, then V equal to IR. So this is the IR. Now from this equation, IR equal to I into, this is the R1 plus R2 plus R3. So R equal to R1 plus R2 plus R3. Okay. And now parallel combination of resistances. Look at this. R1, R2, R3 are connected in parallel across a potential difference V. If I1, I2 and I3 be the current flow through R1, R2, R3, then total current I is equal to I1 plus I2 plus I3. Okay. As all are connected in parallel, so PD across each resistor is V. So look at this. I1 equal to V by R1, I2 equal to V by R2 and I3 equal to V by R3. So look at this. V equal to, so V into 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Now if capital R be the equivalent resistance, then I equal to V by R. So look at this. The equivalent resistance is equal to 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Now look at this. 1 by R greater than 1 by R1, 1 by R greater than 1 by R2, 1 by R greater than 1 by R3. So look at this. R, look at this. 1 by R greater than 1 by R1. So from here R less than R1. In the same way, 1 by R greater than 1 by R2, therefore R less than R2. In the same way, 1 by R greater than 1 by R3, so R less than R3. Therefore, equivalent resistance in parallel combination is smaller than each resistance of the combination, or smaller than smallest resistance of the combination. Okay. Now I will be solving some numerical relating to series and parallel combination. Now look at this. Ncert numerical 3.3. The resistances 1 ohm, 2 ohm and 3 ohm are connected in series across a potential difference 12 volt. We have to calculate equivalent resistance and potential drop across each resistor. Now look at this. The equivalent resistance in series combination is equal to 1 plus 2 plus 3 equal to 6 ohm. Now first of all we have to calculate current. So 12 divided by equivalent resistance, so this is the 2 ampere. Now voltage drop across 1 is V equal to I into R1. So this is the 1 into 2, that is the 2 volt. Here 2 into 2, so V2 equal to 4 volt. And here V3 equal to 2 into 3, so this is the 6 volt. Okay, understood? Now next. Now look at this. Ncert numerical 3.4. Now resistance is 2 ohm, 4 ohm and 5 ohm are connected in parallel across a potential difference of 20 volt. Now we have to calculate the equivalent resistances and current through each resistances. So look at this, the equivalent resistances 1 by R equal to 1 by 2 plus 1 by 4 plus 1 by 5. Now what is the LCM? Look at this, the LCM is 20. So 20 here 10 plus 5 plus 4. So R equal to, look at this, 20 by 19 ohm. Now current through 2 ohm resistances, look at this, I1 is equal to V by R, 20 by the current through 4 ohm, I2 is equal to 20 by 4. So this is the 5 ampere. And current through 5 ohm resistances, now current through 5 ohm is I3 equal to, this is the 20 by 5, that is the 4 ampere. Okay, understood? Now next. Now Ncert numerical 3.20a. N resistances, each of resistance capital R, how can you get the minimum and maximum resistance from this combination? We know the equivalent resistance is parallel combination will be the least. So in parallel combination, the least resistance 1 by R mean, so this is the 1 by R plus 1 by R plus dot 1 by R. Okay. So this will be the R by N. So this will be the N by R. Therefore R minimum is equal to R by N. In series combination, equivalent resistance becomes maximum. So R max, this becomes R plus dot up to N number. So look at this, R max, this equals to NR. Okay. No problem. Next. Now look at this. The resistance is 1 ohm, 2 ohm, 3 ohms are given. How to combine to get 11 by 3, 11 by 5, 6 ohm and 6 by 11 ohm. Now first of all look at this, 11 by 3. Okay. Now look at this. If two resistances 1 ohm and 2 ohm are connected in parallel, then equivalent resistance becomes R1 R2 by R1 plus R2. So look at this, this is the 1 into 2 by 1 plus 2. So look at this, this is the 2 by 3. Now 2 by 3 plus 3 equal to 11 by 3. So parallel combination of this and this are connected in series with 3 ohm. Get 11 by 3. Now look at this. This is the 1 ohm, okay, and this is the 3 ohm. We get 11 by 3, okay. Now this is the 1 ohm, this is the 2 ohm, and this is the 3 ohm, okay. So 11 by 3 ohm is obtained by connecting the resistances in this way, okay. Now to get 11 by 5, this and this are connected in parallel. So look at this, we get 2 into 3 divided by 2 plus 3. So this is the 6 by 5 ohm. Okay, no problem. Now 6 by 5 plus 1, 11 by 5. Okay, so look at this, the combinations are, this is the 1 ohm and look at this, this is the 2 ohm and look at this, this is the 3 ohm. So this is the 2 ohm, this is the 3 ohm. So look at this, 2 and 3 combined to form get 6 by 5 and series with it we get, this is the 11 by 5. Understood? Now next 6 ohm. Look at this, 6 by 11 is less than 1. So all three are connected in parallel. Look at this, this is the 1 by R is equal to 1 by 1 plus 1 by 2 plus 1 by 3. The LCM is 6. Okay. So 6 plus 3 plus 2. This is the 11. 6 plus 3 plus 2. So this is the 11 by 6. So look at this, R equals to 6 by 11. Therefore parallel combination of this, look at this, this is the 1 ohm, this is the 2 ohm, this is the 3 ohm. We get 6 by 11 ohm. Understood? Now next, look at this 1 ohm, 1 ohm, 2 ohm, 2 ohm are connected in this way. We have to calculate equivalent resistance in it. Now look at this 1 ohm, 1 ohm are series, 1 ohm, 1 ohm series, here 2 ohm, 2 ohm are series. So the combination becomes, look at this is the 1 1 2, this is the 2 2 4. Okay, now here look at this is the 1 1 2 and this is the 1 1 4. Okay, so this is the 2 ohm, this is the 4 ohm, this is the 2 ohm, this is the 4 ohm. In the same way, look at this is the 1 1 2, this is the 2 2 4. Now look at this is the 1 1 2 and this is the 2 2 4. Okay, no problem. So look at this equivalent resistances of these are, look at this 2 into 4 divided by 2 plus 4. So look at this 8 by 6, that is the 4 by 3. Now 4 by 3, 4 by 3, 4 by 3, 4 by 3 are in series. So equivalent resistance becomes 4 into 4 by 3. So this is the 16 by 3 ohm. Okay, understood? Next, look at this here. If I be the current enter in this, so current flow through each resistance is same. So they are in series. Therefore equivalent resistances is R equal to 5R. Understood? Now next, look at this, all resistances are of 1 ohm. The combination are connected to a 12 volt battery. Now we have to calculate current drawn from battery. Now look at this is the infinite combination. Look at this. So these type of branches are of infinite number. Okay, suppose equivalent resistance of these combinations is R. So equivalent resistance between C and D is also R, because infinity minus 1 is also infinity. Now look at this is the NB. Look at this is the 1 ohm, this is the 1 ohm, and look at this is the 1 ohm, and here point C and point D. So this is equivalent resistance is R. R ohm, 1 ohm parallel with series with 1 and 1 combined to give R. So look at this, R is equal to 1 plus 1 plus R parallel 1. Okay, look at this 1 plus 1 equal to parallel combination of this and this. Look at this 1 1 parallel combination of this. Now R equal to, this is the 2 plus R into 1 divided by R plus 1. So R minus 2 equal to R divided by R plus 1. From this relation we can get R minus 2 into R plus 1, this equal to R. So this is the R square minus R minus 2 equal to R. So here R square minus 2R plus 1 minus 2 equal to 0. So look at this is the R minus 1 whole square equal to 3. Therefore R equals to root 3 plus 1. Understood? Therefore R equals to 2.73 ohm. And look at this current drawn, I equals to, this is the 12 volt divided by 2.73 plus 0.1. Sorry, this is not the 0.1, this is the 0.5. Here 2.73 plus 0.5. So look at this is the 12 by 3.23. This is the 3.7 ampere. Understood? Now next, look at this. In this topic I will be explaining the EMF of a cell, terminal potential difference of a cell, and the lost volt I into small r in the cell. Now look at this is the positive and negative terminal of a cell. When the cell is in open circuit, the potential difference between positive and negative terminal of a cell is called EMF. Now the terminal potential difference V equal to IR. It is the potential difference between the two terminals of a cell when the cell is in closed circuit. When electrical energy is converted into other forms of energy, then potential difference is produced. It is measured with the help of voltmeter. And when a cell supplies current, the terminal potential difference is less than EMF, and it is the effect of EMF. When other forms of energy is converted into electrical energy, EMF is produced. When a cell supplies current, EMF is greater than the terminal potential difference, and EMF is measured with the help of potentiometer. Okay, suppose I current flow through the resistance. So terminal potential difference V equal to I into R. Okay. Now if small r be the internal resistance of the cell, the internal resistance of the cell is the resistance offered by the electrolytes of the cell. Now internal resistance depends on the nature of the material inside the cell, area of cross section of the positive and negative plate, and distance between the two plates. Okay, look at this, the voltage drop inside the cell is IR. Now so from E equal to the voltage drop outside the cell plus voltage drop inside the cell. Okay, so look at this, I equal to E divided by capital R plus small r is the current flow through the resistance R, or current sent by the cell, or current delivered by a cell. Okay, now look at this, the terminal potential difference V equal to IR. So V equal to IR equal to E into R divided by capital R plus small r. Okay, this is the expression of potential difference in terms of EMF and external resistance of the cell. Now if we put V equal to IR in this equation, we can get E equal to V plus IR. So terminal potential difference IE minus I into R when the cell sends current. Now when the cell is charged, the terminal potential difference V equal to E plus IR. So during charging, the terminal potential difference greater than the EMF. Understood? Since the maximum current sent by a cell, look at this, when external resistance is 0, so I equal to E by small r. So look at this, this is also called short circuit current, the maximum current supplied by the battery, that is EMF divided by internal resistance. For a large voltage supply, the internal resistance of the supply should be large, because if internal resistance be very small, then accidentally if the battery is short circuited, then large current flow through the battery and the explosion may take place. Okay, now look at this, Ncert numerical 3.1. A storage battery in a car cell has EMF 12 volt, internal resistance 0.4 ohm. Now we have to calculate maximum current. Now the maximum current from a battery is obtained when external resistance R equal to 0. That is when the battery is in short circuit. Now short circuit current or maximum current is E by small r. So this is the 12 volt by 0.4. So look at this, this is the 30 ampere. Okay, understood? Look at this, the numerical 3.2. A battery of EMF 10 volt, internal resistance 3 ohm, sends current 0.5 ampere. Now we have to calculate the external resistance and the terminal potential difference. Now we know the current I equal to E divided by capital R plus small r. Look at this here, current I equal to 0.5 ampere and E equal to, this is the 10 volt and R equals to question mark, and this is the small r, this is the 3. Okay, now 0.5, now look at this, 0.5 equal to half, so this is the 10 plus R by 3. So look at this, R plus 3 equal to 20. So R equal to 17 ohm. Okay. Now what is the terminal potential difference? Terminal potential difference V equal to I into R. Now I equal to 0.5, R equal to 17. So this is the 8.5 volt. Okay, 8.5 volt. Understood? Now next, look at this. This is the charging voltage 120 volt. Now a cell of EMF 8 volt and internal resistance 0.5 ohm will be charged with this charger. Now find the terminal potential difference and what is the use of this resistance. Now during charging of a battery, the positive terminal of the charger is connected to the positive terminal of the battery such that the current through the battery from positive terminal to negative terminal. So current is equal to, look at this, 120 minus 8 divided by total resistance. This is the 15.5 plus 0.5. So look at this. This is the 112 divided by 16. So this is the 9 ampere is the current. Now what is the terminal potential difference between the two ends of the cell? Look at this. During charging, the terminal potential difference E plus I into R. So look at this. E is the 8 volt, I is the 9 ampere and R is 0.5. So 9 into 0.5. So finally terminal potential difference is 12.5 volt. Okay, understood? Now look at this Ncert example. This is a cell of EMF 16 volt, internal resistance 1 ohm. It is connected with the series of this and this. Now we have to calculate equivalent resistance, current I and potential difference across AB, BC and CD. Okay. Now look at this. First of all, equivalent resistance. This is the 4 parallel. So 4 into 4 divided by 4 plus 4. So this is the 2. Now this is the 12 into 6 divided by 12 plus 6. Now 12 into 6 divided by 12 plus 6. So this is the 72 by 18. So this is the 4 ohm. Now equivalent resistance, this is the 2 ohm, this is the 1 ohm, 3 ohm and this is the 4 ohm. So equivalent resistance is R equal to, this is the 7 ohm. Now what is the current? Now current I equal to E divided by R plus small r. E equal to 16 volt, capital R 7, small r equal to, look at this, 1. So this is the 2 ampere is the current. Now what is the potential difference between A and B? Now VAB is equal to 2 into equivalent resistance between these two arms. Now equivalent resistance between this and this. So this is the 2. So this is the 4 volt. Okay. Now what is the potential difference between B and C? So VBC is 2 into 1. So this is the 2 volt. And now what is the potential difference? This, the equivalent resistance of this is the 4. Okay. So look at this. VCD is equal to 2 into 4. So this is the 8 volt. Okay. No problem. Next. Now combinations of the cell. First of all, series combination. Look at this. The cell E1 and E2 sends current in the same direction. So here equivalent EMF becomes E1 plus E2. Now look at this. Here E1 and E2 sends currents in opposite direction. So here equivalent EMF becomes, look at this, E1 minus E2. Okay. Now if n number of identical cells are connected in series, then what happens? Look at this, n number cells. Look at this, n numbers identical cells are connected in series. So look at this, all cells send current in the same direction. So equivalent internal resistance E dash equal to N into E. Equivalent internal resistance R plus R plus R plus R. So this is the NR. So current I equal to Ne divided by R plus Nr. Okay, this is the current in series combination. Now, if small r less than capital R, then look at this, I equal to N into E by R. So, from this combination, we get N times current sent by one cell. So, this is advantageous when internal resistance is negligible in comparison to external resistance, then series combinations of the cell are advantageous. Okay, now next. Look at this, n number identical cells, each of EMF E and internal resistance are connected in parallel combination. So look at this, all the cells are connected at the same point. So equivalent EMF becomes E. Now what will be the equivalent internal resistance? Look at this. This is the 1 by R plus 1 by R plus 1 by R. So finally equivalent internal resistance becomes R by N. So current I equals to E. Look at this, Ne divided by Nr plus small r. This is the expression for current in parallel combinations of the cell. Now look at this, if R less than small r, then I equal to N into E by R. So parallel combinations of cells are advantageous when internal resistance is much greater than external resistance. Okay, now in series combination, if m number of cells out of n number of cells are connected wrongly, then look at this, current I becomes n minus m. In now n minus m currents in the same direction and m number of cells sends currents in opposite direction. This divided by R plus Nr. So look at this, n minus 2m into E divided by R plus Nr is the current when m number cells are connected wrongly. Okay, look at this, a numerical. Suppose n number cells, each of EMF E and internal resistance are connected in series across a resistance capital R. Suppose current I1, and these cells are again connected in parallel across the same resistance capital R. If the current flow is same as in above case through the resistance R, what will be the internal resistance of each cell? Now look at this, in series combination, look at this, the current is Ne divided by R plus Nr. This is the I1. In parallel combination also sends current I1, and this is the Ne divided by Nr plus small r. Now equating this, so we get, look at this, Ne by R plus Nr, this equals to Ne divided by Nr plus small r. So look at this, R plus Nr equal to Nr plus R. So R1 minus N is equal to R1 minus N. Now this and this, so R equals to small r. Therefore internal resistance of each cell is equal to external resistance. Okay, now next. Now two cells of EMF E1 and E2 and internal resistance R1 and R2 are connected in parallel as shown. Now we have to calculate the equivalent EMF of this combination E, and equivalent internal resistance of this combination is R. That means this circuit is replaced by this circuit. Okay, now let's start. Suppose V be the potential difference between A and B. So look at this, the terminal potential difference V in this section is, look at this, E1 minus I1 R1, where I1 is the current sent by the cell of EMF E1 and I2 be the current sent by the battery of EMF E2. Okay, Now from this equation we can write I1 equal to E1 minus V by R1. Okay, no problem. Now from this cell the terminal PD V equal to E2 minus I2 R2. E2 minus I2 R2. From this equation I2 equal to E2 minus V by R2. So this is the E2 minus V divided by R2. So total current, look at this, the total current I is equal to I1 plus I2. Okay, here total current is I. Now from this relation we can get E1 by R1 plus E2 by R2 minus V into 1 by R1 plus 1 by R2. Okay, now from this relation we can get V. Now from this relation we have to calculate V. So look at this, V into 1 by R1 plus 1 by R2 equal to E1 by R1 plus E2 by R2 minus I. So here V equal to, look at this, E1 divided by R1 plus E2 divided by R2 divided by 1 by R1 plus 1 by R2 minus I. Look at this, I by this. So this becomes R1 R2 by R1 plus R2. Okay. Now equating here V equal to E minus IR. So look at this. This is the equation 1 and this is the equation 2. So from 1 and 2 we get equivalent EMF E equal to E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2 and R equal to, look at this, R1 R2 divided by R1 plus R2. Okay, this expression will be very helpful for you to tackle the numerical relating to parallel combination. Okay, look at this, 3 volt, 2 volt, 1 volt are connected in this way, and internal resistance of each cell is 1 ohm and this is the external resistance R. Now we have to calculate the terminal potential difference. Now to calculate the terminal potential of this combination we have to consider a cell of EMF E equal to 0. Now terminal potential difference V equal to, look at this, this is the E1 by R1 plus E2 by R2, look at this, E2 by R2 plus E3 by R3 plus E4 by R4, okay, whole divided by, this is the 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, okay, no problem. Now look at this, this is the 3 to 1, so this is the 6 and this is the 3, this is the 1 1 1 plus 0.5, so this is the 3.5. So look at this, 60 by 3.5, so this is the 12 by 7 volt. Okay, now what will be the current through this and this? Okay, now look at this, as current flow through this, so EMF E greater than V. So look at this, if this is the I1, this is the I2, this is the I3, this is the I4. So look at this, I1 equal to, look at this, the direction of current, here cell sends current, so E greater, so 3 divided by 12 by 7 divided by 1. Okay, now look at this, 21 minus 12, so this is the 9 by 1, so this is the 9 ampere. Now look at this, this is the 2 minus I2, 2 minus 12 by 7 divided by 1. So look at this, 21 minus 12, so this is the 9 by 7 ampere. Now look at this, this is the 14, this is the 2 by 7 ampere. Now look at this I3, here terminal PD greater, look at this, here the cell is charging, so V greater than E, so I3 become, look at this is the V minus E3 divided by R. What is V? V is the 12 by 7, So 12 by 7 minus 1 by 1. So look at this. This is the 5 by 7 ampere. Okay. This I4. This is the 12 by 7 minus 0 by 2. So this is the 6 by 7 ampere. Okay. No problem. Next. Now look at this. N cells in each line and number of lines is equal to m are connected in mixed combination. The EMF of each cell is E and internal resistance is smaller. So total number of cell N equal to, this is the M into N. Now look at this. Equivalent EMF in each line is NE and equivalent internal resistance in each line is NR. So these cells will be replaced by a single cell of EMF NE and internal resistance NR. In the same way, this line also replaced by the single cell of EMF NE and internal resistance NR. Now look at this. So this circuit becomes this, and this is the external resistance capital R. Okay. Now this cell and this cell are in parallel combination. So equivalent EMF in parallel combination is just NE and equivalent internal resistance. Look at this, as number of cell is M. So look at this, the equivalent internal resistance is NR by M. So look at this, the current I equal to NE divided by capital R plus NR by M. Okay. Now look at this. This is the NE and now this is the root over of R whole square plus root over of NR by M whole square. Okay. Now this can be written as, look at this. This is the capital R minus NR by M whole square plus 2 into root over of capital R NR by M. Okay. Now current I, now the current I becomes maximum when this term becomes 0. So for maximum current, look at this. This is the root over R minus root over NR by M. This equal to 0. So this is the R equal to NR by M. This is the condition for maximum current. Now to get the maximum current, put NR by M equal to capital R. So I max, this is the NE divided by R plus R. So this is the 2R. So main formula of this combination is here current, and this is the maximum current. This is the condition of maximum current, and total number of cells in the mixed combination is M into N. Okay, remember it. Now next. Now look at this, the related numerical. Look at this, that 90 cells, each of EMF 6 volt, internal resistance 1 ohm are connected in mixed combination across a resistance 10 ohm. Find the maximum current and how the cells are arranged. Look at this, the number of cells in each line be N and number of lines be capital M. So the total number of cell M into N, this equal to 90. Now the condition for maximum current, capital R equal to NR by M. Now here R equal to 10 ohm and N into smaller 1, and this is the M. So look at this, from here N equal to 10 M. Now look at this, here M into 10 M, this equal to 90. So M square equal to 9, therefore M equal to 3. If M equal to 3, then look at this, N equal to 90 by M, so this is the 30. Therefore number of cells in each line is 30 and number of lines is 3. Understood? Now maximum current. Now look at this, I max, this is equal to Ne divided by 2 into capital R. Now N equal to 30, E equal to 6 and 2 into R is 10. So look at this is the 9 ampere is current through the capital R 10 ohm. Understood? Next. Now shunt. Shunt is a weak resistance connected in parallel with a galvanometer to protect it from excessive current. Now the use of shunt, first of all, to protect the galvanometer from excessive current, to reduce the equivalent resistance of ammeter circuit, and it increases the range of ammeter. Okay, now we have to calculate shunt current and galvanometer current where total current is I. Now look at this, the I current divided into Ig plus Is. Okay, if VA and VB be the potential at A and B, now look at this, VA minus VB, so this is the Ig into G equal to Is into S. So look at this is the Ig by Is equal to S plus G. Now adding 1 with both sides, so 1 plus Ig by Is equal to 1 plus S by G. So from this equation we can write Is plus Ig divided by Is equal to G plus S by G. Now Ig plus Is equal total current I, so I by Is equal to S plus G divided by G. Therefore Is equal to I into G divided by S plus G. In the same way, if we find Ig equal to I minus Is, we can get Ig equal to I into S divided by S plus G. Okay, these two relations is very important to find the current between the two resistance connected in parallel combination. Okay, now next. Now look at this, Kirchhoff's law. Kirchhoff's law is very important in finding the current of branches having different lobes. Now Kirchhoff's first law. Kirchhoff's first law is also called junction law. Look at this, the statement is the algebraic sum of current meeting at a point is 0. The incoming current is taken as positive and outgoing current is taken as negative. Now look at this. This is a meeting point of the current. Look at this, I1 is the incoming current, so it is taken as positive. Now I2, I3 and I4 are the outgoing currents, so they are taken as negative. So this is the minus I2, this is the minus I3, this is the minus I4. So sum of these four current becomes 0. So this is the 0. Therefore I1 equal to I2 plus I3 plus I4. Therefore incoming current is equal to outgoing current. This law is obtained from the conservation of charge. Okay. Now Kirchhoff's second law. It is also called voltage law or loop law. Now the statement, the algebraic sum of potential difference in a given loop is 0. The rise of potential is taken as positive and fall of potential is taken as negative. Now look at this. Suppose current flow along this direction and this is the current I and this is the R. So this is the point A, this is the point B. As current flow from A to B, so look at this potential difference. Look at this, the potential difference is I into R. Now if we go from A to B, so look at this, the voltage decreases, so IR taken as negative. So in this direction IR is negative. But now if you move from B to A, so IR becomes positive. So look at this, in the direction of current potential decreases, so in the direction of current IR is negative. Okay. and opposite to the direction of current I are positive. Now in case of a battery, look at this. If we move from this direction, we move from higher potential to lower potential, so potential decreases. If E be the EMF, so along this direction, this is the minus E. If we move from this direction, potential rises, therefore E is taken as plus E. Okay, understood? So main concept is the rise of potential is taken as positive and fall of potential is taken as negative. Now take an example. Now take the loop A, B, C, D, A. From loop, in the loop A, B, C, D, A, look at this. From A to B, look at this, the potential rises, negative to positive, so E3 becomes positive. Now, if I be the current, so IR3 is in the direction of current, so this is negative IR3. Now look at this, again, positive terminal to negative terminal, so look at this is the minus E2. Now look at this, from C to D, we move C to D, that is in the direction of current, so minus IR2 negative. Again from D to A, look at this, in the direction D to A in the direction of current, so this is the minus IR1. And again from negative to positive potential, so potential rises, so this is the plus E1, this is equal to 0. Okay. This law is obtained from conservation of energy. Now take an example. Now look at this, at the point A, I3 current is divided into two branches, I1 and I2. So look at this, I1 plus I2 equal to I3. Okay, this is equation number 1. Now considering the loop, look at this, A, B, C, D, A. In this loop, we move from A to B, there is no potential difference. Now from B to C, look at this, B to C is in the direction of current, so IR is negative. So look at this is the minus 30 I1. Now there is no potential difference from this point. Now here negative to positive potential, so this is the positive. Okay. Now again this is the in the direction of current, so minus 1 into I3, and here minus 40 into I3. So finally this becomes minus 41 I3, this equal to 0. Okay. Now look at this, here I3 equal to I1 plus I2. Now look at this is the 30 I1 plus 41 I3, I3 means I1 plus I2, and this equal to 40. Now this is the 41 I1 plus 30 I1, so this is the 71 I1 plus 41 I2, this equal to 40. Okay, this equation is equation number 2. Okay, look at this, in the loop A, D, E, F, A. Look at this, A to D opposite to the direction of current, so IR is positive. So look at this is the 40 plus 41, so plus 41 into I3, and now this is the positive to negative potential, so this is the minus 45. Now from this is the also opposite to the direction of current, so this is the plus 20, this is the I2, and again this is the opposite to the direction of current, so this is the plus 1 into I2, and this is the positive to negative, so this is the minus 80, this is equal to 0. Okay. Now look at this is the 21 I2 plus 41 I3, this equals to 125. Now I3 equal to I1 plus I2, so look at this, 21 I2 plus 41 into I2 plus I3, this equals to 125. So look at this is the 41, this is the 41 and this is the 21, so this is the 62 I2 plus this is the 41 I1, this equals to 125. Now this equation is equation number 3. if we solve equation 2 and equation 3, we can easily calculate the I1 and I2. If I1 and I2 are known, we easily calculate the current I3. Okay, understood? Now next. Now look at this. This is the unbalanced wheatstone bridge. We have to current I1, I2 and I3. Okay, now look at this in the branch A, B, D, A. Look at this AB in the direction of current. So look at this. This is the minus 10 I2. And look at this. This is the opposite to the direction of current. So this is the 5 I3. And this is also opposite to the direction of current. So this is the 5 into I1 minus I2. Okay, no problem. And this is equal to 0. This is the minus 15 I2 plus 5 I3 equal to minus 5 I1. So look at this. This is the 3 I2 minus I3. This is the I1. So this equation is equation number 1. Now look at this in the loop B, C, D, B. Look at this. Here B to C in the direction of current. So this is the minus 5 into I2 plus I3. Now this is opposite to the direction of current. So this is the 10 into I1 minus I2 minus I3. And this is the direction of current. So this is the minus 5 I3 equal to 0. Dividing by minus 5. So this becomes I2 plus I3 minus 2 into I1 minus I2 minus I3, and this is the I3 equal to 0. Okay, this is the I2 and this is the 2I2. So this is the 3I2. And now I3 plus 2I3 plus I3 plus 4I3, this equal to 2I1. Okay, this is equation number 2. Now solving equation 1 and 2 we can get, look at this. This is the 3I2 minus I3 equal to I1. So look at this, minus minus plus, this is the minus. Look at this, this is the 5I3 equal to I1. So here I3 equal to I1 by 5. Now if we put here I3 equal to I1 by 5, so look at this. This is the 3I2 minus I3 means minus I1 by 5 equal to I1. So look at this. This is the 3I2 equal to 6I1 by 5. So I2 equal to 2I1 by 5. Okay. Now look at this in the loop A, D, C, E, F, A. Okay. Look at this. This is the minus 5 into I1 minus I2. And this is the minus 10 into I1 minus I2 minus I3. Okay. And look at this. This is the plus 10 and this is the minus 10 I1. This equal to 0. Now dividing whole equation by minus 5. So you get, look at this. This is the I1 minus I2. This is the plus 2 into I1 minus I2 minus I3, and this is the 2I1, this equal to 2. Now put the value of I3 and I2 in this equation. So look at this, I1 minus I2, so this is the 3I1 by 5. Now look at this. Now look at this, I3 plus I2, so this is the 3I1 by 5, so I1 minus 3I1 by 5, so this is the 2I1 by 5 plus 2I1 equal to 2. Now look at this, this is the, look at this, this is the 4 and this is the 3 and this is the 10, so this is the 17I1 by 5 equal to 2. Look at this, I1 equal to 10 by 17 ampere. Okay. Along AB current is I2 and this equals to 2I1 by 5. So this is the 2 into 10 by 5, 10 by 5 into 17. So this is the 4 by 17 ampere. Look at this current through AD. So this is the I1 minus I2. So this is the 3I1 by 5. So 3 by 5 into 10 by 17. So this is the 6 by 17 ampere. Okay. Now current through DB is equal to I1 by 5. So look at this. This is the 2 by 17. Okay. Understood? Now next. Now look at this wheatstone bridge. Look at this P, Q, R, S be the 4 resistances of a wheatstone bridge. Now P and Q are called a ratio resistance. R is variable resistance and S is unknown resistance to be measured with the help of wheatstone bridge principle. Now a galvanometer is connected between B and D, and a battery of EMF E is connected between the point A and C. In wheatstone bridge, the position of galvanometer and battery can be interchanged. Now first of all, I current from the battery, and this I current divided I1 along the P and I2 along the R. Now the current through galvanometer depends on the potential of V, the potential of B and potential of D. If VB greater than VD, then current flow from B to D. Now the variable resistance is so adjusted such that potential of B is equal to potential of D. In this case, no current flow through the galvanometer. This is called null condition. In null condition, we have to prove P by Q equal to R by S. As current through the galvanometer Ig is equal to 0, so current through P is equal to current through Q, and current through R is equal to current through S. Now applying Kirchhoff voltage law in the loop A, B, D, A. So we get, look at this, this is the, in the direction of current, potential difference is negative. So minus I1 into P. Now look at this, here minus Ig into 0, and look at this, this is the opposite to the direction of current, so I2 into R equal to 0. Okay, understood? Now look at this, I1P equal to I2R. So look at this, I1 by I2, that is R by P. This is equation number 1. Okay, look at this, in the loop B, C, D, B, we get, look at this, this is the direction of current, so minus I1 into Q. This is the opposite to the direction of current, so this is I2 into S, and this also the opposite to the direction of current, so 0 into Z. Okay, and this is equal to 0. So from here, look at this, I1Q equal to I2S. So I1 by I2 is equal to S by Q. This is equation number 2. Look at this, from 1 and from 2 we get, look at this, R by P is equal to S by Q. So here P by Q equal to R by S. Okay, understood? Next. Now look at this, this is a meter bridge. Here the principle of wheatstone bridge is used. Now look at this, between A and D resistance R is connected. Between D and C resistance S is connected. And between A and B, the one portion of the meter bridge wire is act as a resistance P and other end act as a resistance Q. Now first of all, Now a battery is connected between A and C. So when current passes through it, first of all, jockey touches here. Now a deflection obtained. Now this jockey is connected the other end. If the opposite deflection occurs, then our circuit is correct. Now we proceed our main experiment. Now the null point is moved towards the midpoint. Suppose at the point P, the null point is obtained. Null point is obtained means there is no current passes through the galvanometer. So wheatstone principle can be applied. Now if resistance per centimeter of the meter bridge wire is lambda, so P equal to lambda into L and Q equal to, look at this is the 100 into L into lambda. Now L is the length of AB. Now applying the wheatstone principle, P by Q equal to R by S. So look at this is the lambda L divided by 100 minus L into lambda, and this is the R by S. So look at this. Now unknown resistance S is equal to 100 minus L into R divided by L. Okay. This formula is utilized to find the unknown resistance S. Now the relative error delta S by S is equal to, look at this, here relative error of 100 L minus L plus relative error of L. Okay, so the relative error becomes minimum if null point is obtained just at the midpoint. That is why the null point is obtained near the midpoint of a meter bridge wire. Okay, understood? Now next. Now potentiometer. The potentiometer is used to measure the EMF of a cell, comparison the EMF of two cells and internal resistance of the cell. If we measure the EMF of a cell with the help of voltmeter, the voltmeter reading V equal to E minus IR. That is, voltmeter reading is slightly less than E. Look at this. Here due to lost volt, V less than E. Therefore, voltmeter can't measure the EMF accurately. If we measure the EMF of a cell with the help of potentiometer, the current through the cell at the null point is 0. So V equal to E minus 0 into R. So this is the V equal to E. So potentiometer measures the EMF of a cell accurately. Okay. Now look at this. This is a long wire. Look at this. This is the long wire of a potentiometer. It may be 6 meter, 8 meter. Generally, it is 10 meter. Now it is connected with a driver cell E0, a key K0, a variable resistor RH and an ammeter A in series with it. Okay. So look at this. If length of the potentiometer be L and resistance capital R, so resistance per unit length lambda equal to R by L. Okay. So current through the potentiometer I equal to E0 divided by R plus variable resistance RH. Now potential difference across the potentiometer wire VAB, this equal to I into R. So this is the I lambda L. Now the potential difference per unit length, that is VAB by L equal to potential gradient is equal to lambda I. To measure the EMF of a cell, the positive terminal of a battery is connected to the point A and its negative terminal is connected to the galvanometer through a resistance box of high resistance. If similar null point and AC equal to L, then EMF of the cell E equal to, look at this is the lambda IL. So relative error in measurement of EMF delta E by E equal to delta L by L. Now there is a very important point to discuss in context of potentiometer. The EMF of driver shunt E naught greater than the EMF of cell to be measured. The relative error delta E by E equals to delta L by L. So relative error becomes minimum if L is large. Now L becomes large if I becomes small. Now I equals to E naught by R plus RH. So I becomes small if resistance of variable resistor is high or resistance of potentiometer is also large. A resistance box is the safety device for galvanometer. If high current passes through the galvanometer, then the galvanometer may get damaged. So to protect it, a high resistance is connected in series with the galvanometer. Near the null point, a short circuit key is added here to get the null point. Okay. Now the EMF in order of microvolt can be measured with the potentiometer. If we measure the EMF in the order of microvolt, the null point is very close to the point A. If null point is very close to the point A, so delta L by L is large. So relative error is large. So very small potential difference is not measured with the help of potentiometer. Now to measure the very small potential difference with the potentiometer, the variable resistance increases in such a way that current through the potentiometer is very small. In this case, the L becomes large and the potential in the order of 1 microvolt can be measured. Okay. Now next, comparison of EMF. Now to compare the EMF of a cell, the positive terminals of the two cells are connected to the point A and the negative terminals are connected to the galvanometer through the 3OA key. Now suppose a key K1 is connected, then the terminal 1 and 3 is added. Now the key K2 is closed, the terminal 2 and 3 are connected. Okay. Now look at this. Suppose, now look at this. The switch K2 is open and K1 is closed. The null point is obtained at C1. If distance of C1 from A is L1, then E1 equal to potential difference across AC1. Now PD across C1 means potential difference per unit length into length of AC1. This is equation 1. Now switch K1 is open and K2 connected between the cell E2 and galvanometer. If null point is obtained at C2, now length of AC2 equal to L2, then E2 equal to potential difference across AC2. So E2 equal to, look at this, this is the lambda I L2. Now E1 by E2, this equals to L1 by L2. Okay. Now next. Now to measure the internal resistance R of the cell E, the cell E is shunted by resistance R. When switch K is closed, the terminal potential difference of the cell is V equal to E into R divided by capital R plus small r, where small r is the internal resistance of the cell. Now switch K is open. The null point is obtained at C1. If AC1 equal to L1, then EMF E equal to PD across AC1. So this is the potential difference per unit length into length. Now the key K is closed. So terminal PD across the cell is this. The null point is obtained at C2. If AC2 is equal to L2, then terminal PD V equal to lambda I L2. Okay? Now look at this. V by E is equal to L2 by L1. Now from this relation, V by E equal to R by R plus R equal to L2 by L1. So R plus R by capital R equals to L1 by L2. So 1 plus R by R equals to L1 by L2. So R equal to capital R. So small r equal to capital R. This is the L1 by L2 minus 1. So R into L1 minus L2 by L2. Okay? Understood? Now look at the numericals. Now Ncert 3.10. Look at this. X and Y are the resistance in the gap AB and in the gap BC. Null point is obtained 39.5 cm from the end A. Y is given. We have to calculate X. Now look at this. From this condition, X by Y is equal to L by 100 minus A. Now here X is unknown, Y equal to 12.5 and this is the 39.5 and 100 minus 39.5, that is this is the 60.5. Okay, so look at this. X equals to, this is the 39.5 by 60.5, so into 12.5, this is almost 8.2. Okay, now next question. If X and Y are interchanged, what will be the value of X? If X and Y are interchanged, so look at this. This will be the Y and this is the X. Now look at this here. Y by X and this will be the null point L divided by 100 minus A. Now look at this. X by Y is equal to 39.5 by 60.5. So Y by X equals to 60.5 divided by 39.5. This equals to N divided by 100 minus A. Okay. So look at this. This is the 6050 minus 60.5 N and this is the 39.5 N. So 6050 and this is the 100 N. Okay. So look at this. L become 60.5. So null point is obtained at 60.5. Understood? Next. Ncert 3.12. When a cell of EMF 1.25 volt is connected in a potentiometer to measure its EMF, the null point is obtained at a distance 35 cm from a point of higher potential. Now the cell is replaced by another cell. The null point shifted to 63 cm. What will be the EMF of the cell? Now apply the formula, the comparison of EMF E1 by E2 equal to L1 by L2. So this is the 1.25, this is the E2 and this is the 35 divided by 63. Now this is the 5 and this is the 9. So E2 equal to, look at this, 1.25 into 9 divided by 5. So this is the 0.25 into 9. So this is the 2.25 volt. Okay. understood? Now next. Now look at this. This is a potentiometer circuit. This is the driver cell. Smaller is its internal resistance. And look at this. This is the EMF. Now this is the cell of EMF 1.02 volt to be measured with the help of potentiometer. This is the high resistance connected in series with the galvanometer to protect it from the excessive current. The EMF of the cell is 1.02 volt and null point is obtained is 67.3 centimeter. Now this cell is replaced by another cell of EMF E. The null point is obtained 82.3 centimeter. Find the value of E. Okay. And what is the purpose of it? The purpose of 600 kilo ohm resistance does not affect the null point. It protects the galvanometer from excessive current. Okay. Now apply the comparison of EMF 1.02 by E equal to L1 by L2. This is the L1 and this is the L2. So this is the 67.3 divided by 82.3. So E equal to, look at this, this is the 82.3 into 1.02 divided by 67.3. Okay, this equal to almost 1.25. So EMF of the cell is 1.25 volt. Okay, understood? Then next, this is the Ncert 3.24. Now look at this. This potentiometer measures the internal resistance of the cell. To measure the internal resistance of the cell, the cell is shunted by a resistance of 9.5 ohm. When only cell is used, the null point is obtained at C1. When it is shunted by resistance this, the null point obtained at C2. Here AC1 given, AC2 is given. We have to calculate the internal resistance. Now internal resistance R equals, now internal resistance small r is equal to capital R into L1 minus L2 by L2. Now look at this. This is the L1, this is the L2, and R equal to this. So small r equal to, look at this. This is the 9.5 and this is the 67.3 minus 64.8 divided by 64.8. Okay, so internal resistance is equal to almost 1.7. Okay, understood? And many thanks for watching this video. This is the complete discussion of current electricity. This discussion helps you in CBSE examination, in NET, in main and advanced. Please like, share and comment on this. And if you are new, don't forget to subscribe my channel.